All right, so the exit slip from yesterday. Here we go. So these are our theoretical probabilities for spinning an A, spinning a B, and spinning a C. So you can tell that it's a non-uniform probability model. And so A would be 1/4. And so if I look at problem A right there, we're pretending we spin the spinner 12 times. And so it's asking for us to make a prediction of how many times would be A. All right. And so I kind of set up my proportion like this. Then I can think of cross multiplying 12 times 1 is equal to 4 times A, or 12 is equal to 4A. And then A would be equal to 3. And so for that first one, my answer is going to be 3. Okay. Let me adjust that a little bit. I kind of liked it because I could. Okay, that's a little better. Just the focus. Okay, sorry about that. All right. Then the next question for that is saying the probability of spinning B. Well, my probability for B is 1/3. So now I'm going to have it 1/3 equals B over 12. All right. And then I'm going to cross multiply again, and then it would be 12 times 1 equals 3 times B. And then it would be 12 equals 3B. I divide by 3, I divide by 3, and then 4 is equal to B. And so that's my prediction based on the theoretical probability. If I spun it 12 times, I would get 4 B's, I would get 3 A's. This is my prediction. And then last for C, the theoretical probability there is 5/12. So I do the same thing, and this is going to be an easy one. And I was cross multiplying, which works every time. But if I look at this here, I can kind of consider these to be equivalent fractions in a way, equivalent ratios actually. To get from here to here, I times it by 3. I also times this by 3 to get to 3. I times this by 4, or times this by 4 to get to that. This one is times 1 and times 1. And so for this one, C is going to just equal 5. And let's see if that makes sense. I'm spinning it 12 times, so 5 and 4 and 3 is going to add up to 12, and that would make sense since these are all of my options right here, A, B, or C on the spinner, okay? And so that's what I would have for part A. Now I need to go to part B. Part B is the same situation. It's just saying now that instead of 12 times, I'm spinning this 96 times. And so I can set up all of my parts the same exact way. And so I use the theoretical probabilities, but I just input 96 in for the whole now to figure out what that is going to be. Okay. Again, I'm going to cross multiply. I can cross multiply and then divide by, or I can scale up. Either way is going to work here. And so if I look at this right here, that would be times 24. And so A would be 24 times, because I'd multiply that by 24. Then 3 times 32. So this times 32. And so B is going to equal 32 times. Then I could do the same thing here. 12 times 8 is going to be 96. And then 5 times 8 is going to be 40. And then I can double check. 40 plus 32 is 72. 82, 92, 96. When I add them all together, I get all 96 trials. This is a prediction of how many A's I would get if I spun it 96 times. All right. Last but not least, we have 6,000. All right. So same thing. 1/4 is equal to something over 6,000. 1/3 is equal to something over 6,000. And then 5/12 is equal to something over 6,000. Okay. I could cross multiply to get A, B, and C for my predictions, or I could scale up. This times, let's see here, 1500, and so A should be 1,500. This times 2,000. So 1 times 2,000 is going to be 2,000. And then 12 times 500. So 5 times 500 will equal 2,500. And if I add these together, 2,000 and 2,500 is 4,500, plus 1,500 is all 6,000 there, okay? And so I'm using my theoretical probabilities to set up a proportion. I'm solving that proportion to predict how many times I would, in an experiment, have an A on the spinner, a B on the spinner, or a C on the spinner. All right, so now we're looking at number 2. And as we're looking at number 2, I want to see here. Okay, as I'm looking at number 2, first of all, what I wrote here is I wrote rolling a 1, 2, 3, 4, 5, 6, and then I counted the tallies. So, and then the top section here says a 6-sided number cube was rolled 30 times. Okay, so use the results listed in the table to answer each question. All right, and so now I'm going to answer all of those questions. A, what is the theoretical probability of rolling a number less than 4? Well, less than 4, an outcome would be 1, 2, or 3. When it says theoretical, they're talking about not having the experiment, so not looking at this, but just looking at what the outcomes are. So there are 3 outcomes that would be less than 4. And then there are 6 total outcomes. All right, and I'm fine with that. I could rewrite it as in lowest terms. I could write it as a decimal. I could write it as a percent. For most of this, we're doing fractions for most of these probabilities, though. Okay. B now says, what is the experimental probability? So now we're looking at the experiment, actually. And so if I look at this, we had 8 out of 30 for rolling a 1. We had 2 out of 30 for rolling a 2. And we had 8 out of 30 for rolling a 3. So we can add those up and we would get 18 out of 30, which I could rewrite as 9 over 15, but I can simplify that more if I wanted to, and I could write it as 3 over 5. 3 over 5 is the same as 6/10, which is the same as 60%. Okay? So theoretical is just looking at what the outcomes are and thinking about what they would be. Experimental is looking at the experiment that we conducted or that they conducted there, and they're looking at the results. Okay. Problem C says, what is the percent error for probability of less than 4? All right. So percent error, if I remember correctly, is the probability of the experiment minus the theoretical probability. You do that first. You divide it by the theoretical probability, then you times it by 100 to get a percent. Okay. When I was noticing when that number is negative, then it was below the theoretical. When it's positive, it was above the theoretical probability. So if I take a look at this, we can go with I say we go with like our initial one right here, the 18 over 30, because that's easy to work with. So if I'm solving this, popular, 18 over 30 was the experimental, minus 15 over 30. Where did I get the 15 over 30? Where did I get the 15 over 30? Well, my probability was 3/6. I just converted it into 30ths, so it's easier to work with. 15 30ths is the same as 3/6. I would divide that all by 15 30ths, and then I would multiply that by 100. Okay? Now, solving this, 15 30ths minus, 18 30ths minus 15 30ths is going to be 3/30. Then I could think of this as 3/30 all over 15/30. And that is a crazy complex fraction. We looked at that earlier in the year. We were all confused. I wasn't. But 3/30 divided by 15/30 is the same as taking 3/30, keep it, inverse operation by the reciprocal. I would always reduce this first. So 30 over 30 is equal to 1. 3 over 15 is equal to 1 over 5. And so then this would be 1/5. 1/5 times 100 is going to be equal to 20%. Because 1/5 is the same as 0.2. 0.2 times 100 is going to be 20%. And so my answer for C, the percent error, is going to be 20%. Okay? Definitely a hard thing to learn from this whole topic. They're going to do this one more time, but now with just rolling a 2. All right? And so for D, rolling a 2 is going to be theoretical. Sorry. There's 1, 2, so it'd be 1 over 6. 1 over 6 is equal to 0.16 repeated, which would be the same as 16.6% repeated. All right, like that. If I don't round any of the percents or anything like that. And I just know that you could figure it out by taking the numerator, divide it by the denominator. Every fraction is a division. Every division is a fraction. You would get this decimal. Multiply this decimal by 100 to get to this percent. Okay. The experimental probability of rolling this is 2 out of 30. So I'm going to, for E, it asks for the experimental probability. So it's going to be 2 out of 30, which I could rewrite as 1 over 15. Here is where I would actually have to take my calculator. And I will do so. And I take 1 divided by 15, and I get a decimal of much smaller, of 0.6 repeated, which is the same as 66.6% repeated. No, sorry. Ooh, mistake. Which is the same as 0.06 repeated. Mr. Molnar is making mistakes, which is going to be equal to 6.6% repeated. Oops. Then it says, what is the percent error for this one? Oh boy, it'll be the same kind of situation for F. Okay, so think about what we just did and look at what this is going to be. It is the experimental probability, so 2 out of 30, minus the theoretical probability, which would be 5 out of 30. Where did I get 5 out of 30? I took 1/6 and I made an equivalent fraction that had 30 as the denominator. I would divide this all by 5 over 30, and then I'm going to times it by 100. Okay, step 1. Step 2, I would have 2 over 30 minus 5 over 30, which is going to be negative 3 over 30, all over 5 over 30 times 100. And that's step 2. Step 3, this is a crazy complex fraction, which I can rewrite as negative 3/30 divided by 5/30, which I could then rewrite as keeping that the same, 3/30 times 30 over 5. If I reduce 30 over 30 is equal to 1, then this is going to be equal to negative 3/5 times 100. 3/5 is equal to 0.6, negative 0.6. Negative 0.6 times 100 is going to be negative 60%. And so my experimental probability was 60% lower than what I would expect from the theoretical probability. And then last but not least, G says, how might you adjust the experiment to decrease the percent error? Have more trials. The more trials you do, the closer you're going to get to having the the theoretical probability. So the more trials you do, you get closer to the theoretical probability in your experiment. I'm sorry that was long, but I do want to keep on going over these tricky problems to make sure we understand what's going on there. And so we are better equipped to answer those. All right. So buttons, good luck to you.